computing is failed, basically, why it can't work. Overview, what currently goes on in the cloud scene. So how's a status report currently? What I think has to be done to solve or enable the cloud to grow even more, and what can be done to make it suck a little bit less. A little introduction of objects, that's my solution proposal. Basically what I think can happen with the cloud, or I hope it will happen, obviously. And a little outlook what I think the future will hold for the cloud. What this talk will not be, and please, if you sort of thought this would be it, please leave. It will not be an introduction what the cloud is. Everyone has a different definition, and just accept that no one knows what it is. It's just a marketing word. It won't be about programming. I won't teach you the if, then, else. A comparison between Amazon and Google, and I don't know. I don't want to compare different cloud services. I don't want to say Google or Amazon is better than Microsoft's cloud, or that's for everyone else to decide, or decide for yourselves, to be honestly. It won't be absolutely unbiased. I do have a bias on certain things, obviously, like every guy has, and it will definitely not be politically correct. So please don't be offended if you, or tell me if you are, and I won't care. So every time I told people I'm writing my dissertation about objects in the cloud, lots of people said interesting things. So said, are you writing about airplanes? Are you writing some sort of airplane system? Some people said, are you writing about rain or clouds, or I don't know. And some people said, are you talking about birds? And of course, angels. A very pretty angel here. So no one really knew what the cloud was or what objects in the cloud should be. So actually, it's none of that, as you might have guessed. Objects as in C++, Java, Python, whatever objects. So if you're all familiar with object orientation, we have a little example here, the model view controller. So you have the model object, the view object, and you have all these objects that can talk to each other, can interact with each other. And object is a confined sort of, it creates functionality, and data is held in an object. So in a way, it's secluded to the outside world. This is one of the most used examples for object orientation. So you have to see objects as in programming objects, something you can't actually touch, something that's just a model. At the end of the day, it's just a structured memory. But you have to see an object as a C or programming objects. And so the idea I had was why kind of have the model and the controller in the cloud, because Amazon already holds all my data on their cloud, whatever, and have my controller hosted by Google because they've got really nice markup libraries and they've got nice JavaScript bollocks. But why do if I go for a cloud service provider, why do I have to host everything in Google? Why can't I have my data on the Amazon cloud, have the controller on another Google cloud, and have my view locally on my computer? What would be quite nice on a very slimline view, you could have it on your PDA, for example, or on your iPhone, HTC Touch or whatever. So sort of it would be very nice to have this. I thought while sort of thinking about this. But what is the problem with the cloud? Why does the cloud suck so much? Why does everyone, as soon as you say cloud computing, say, oh my God, it's just another buzzword, Web 2.0? Actually, it's a good idea, but everyone's really pissed off with it. And so what has moved into the cloud? Hardware has definitely moved into the cloud. I mean, if you go to the Sun website, you see cloud, massive. IBM is only talking about cloud hardware. So the cloud, the hardware providers, basically they've got Blade servers and I don't know what. The OS, I mean, Xen and everything's pretty much moved, and you can have as many virtual hosts as you want nowadays on a machine. And it's sort of, I think OS is pretty much cloud-enabled, if you want to define it like that. But the software is not. And now lots of people say, oh my God, the only thing I thought that was actually in the cloud is the software. But now comes a problem. Let's say you write a little bookshop, and you host it on the Amazon or Google cloud. You write your program, and then you sort of figure some way down the line, people will actually have to access my data in some form or some XML format or whatever. And so what happens is you've got your core program, and then you wrap a layer around it, or an output filter. So every time someone queries your data, you say, okay, it goes into your program. you do something with it, and then you get an object normally, and then you wrap this in some sort of output format. So you create some XML, some YAML, or whatnot. So there are lots of techniques to do that. There's SOAP, what's quite predominant, Corba, what sort of everyone's talking about, but no one really implements it except GNOME, and they bitching it again, and I don't know. There's a lot of middleware research, or a lot of middleware companies that promise great things, and none of them work that I've tried. So software is not cloud-enabled. Everything that you say is written in the cloud is service provider locked. So if you go with Google, you have to use their storage service, you have to use their Python, whatever programming language, you're locked on that provider. If you choose to go with Amazon, that's it. You have your virtual machine on Amazon, that's it. If you go with Microsoft, you have to use .NET, you have to use their storage, I don't know what it's called, but you're locked in. So everything that's written now that is cloud computing is locked in on one provider, and you've got your core program, and then your outside world is a layer around your core program. And I thought this is sort of stupid, because actually the cloud is about interchangeability. So the current state of affairs is you've got your Google Cloud, you've got your Microsoft Cloud, you've got your AMD Cloud. So you have loads of single clouds. You don't have one big cloud. Everyone has his own cloud. Everyone has his own definition of clouds. So you've got loads of little clouds, but you don't have one big cloud, what you'd actually want. Because that's where the power is of the cloud, that you have all the services in the cloud. You don't have lots of little service clouds. So to explain this a little bit more, your typical build-up in a normal company or whatever you do is you've got your locations, you've got your home, you've got your office, maybe you've got another office and you've got some sort of production site or the office of your girlfriend, wife. Might have firewalls between this. You've got your users, that might be everything, and you've got your devices. So nowadays everyone has a phone that can do more than my first computer that I bought. You've got iPods that can browse the web, you've got everything, and you've got a number of applications. Sorry. So you've got your writing apps, you've got your mail, you've got your calendar, you've got your files. And now the problem is, what lots of people say, oh, okay, I write this file on this device, but I can't view it on that device, I can't go on that location. And so it isn't really interchangeable. When you're at home, you might be able to use an FTP server to upload your files, but if you're behind a firewall, that will not work if you're at work. And so you've got all these devices that actually are not really interchangeable either. So here comes the power of the cloud. Because why can the applications not live in the cloud, and the only thing you really get is a view, the model view thing. And that was my idea sort of for the future, or what I would really like. It's because I've got a big problem. I've got 4 laptops, I'm at different locations, I go to university, I'm at home, I go to my parents' place, and I can't really use a whole application suite. I always have to customize. If I'm working on a Mac, I can't use some programs I use on my Linux machine, and so on. So the cloud landscape that you have now is that you've got loads of separate clouds, and I think this slide should have been one before, actually. And they talk through SOAP. What's a horrible XML format, bias here. I hate XML, I hate SOAP. I'll show you why. So you've got all these clouds. So you've got your Brightly application in one Google Cloud. You've got your Dropbox there or your file server or whatever in this other cloud. But can you save your Google or your Google Doc files to the Dropbox account? Not really, except if you save them on your local PC and then you upload them again. Wouldn't it be funky to have your Google Doc file edited in Google Docs, but save it on your Dropbox account, where you actually might be paying for the service or something? But no, like this now, I pay for my Picasa photos, I pay for my Dropbox, so I'm paying for 10 different people, but actually I just want one big hard drive where all my stuff is hosted. And I don't want to be locked into one service. I don't only want to use Google Calendar. I want to use whatever calendar I see fit, but I should have access to my data. So what's the solution? And the solution I came up with is distribute objects. We all know object orientation. We all program objects, and every day. Why does the object I have locally on my computer, why does it have to live on my computer? Why can't that object just live somewhere? why do I care where this object lives? I mean, I don't care where my email is hosted anymore. Who has Hotmail, Google Mail account or something like that in the audience? Yeah. Where's your email host? Where's actually your email? Where is it? I mean, for me, my email is the most personal thing I have. I've got all my credit card information in there. I've got my... Exactly. I mean, for me, my email, if someone would hack my email account and actually would want to steal my identity for some reason, he could do that easily. He would know everything about me. And he would know where I am at what place because people send me, oh, okay, yeah, we're going to meet here at that place. So he'd know my room would be empty. He'd know my address because I get all the Amazon confirmations with my address on it. So if he hacked my email, that's it. But I've got no idea where my email is. It's on some Google server. Do you know Google is protecting this correctly? It's a big corporate American company. No offense to the Americans, but who is reading your email, really? I mean, do you know Google employees? Do they think they can read your email? Is it encrypted? I'm not going to say if it's not, but... So I thought, why not distribute objects? Why can't we create one big cloud where everything is shared? So a little example how I imagined this. This is actually sort of, I wrote a paper, when I sort of started this idea, I wrote a paper about a guy called Dave, how I imagined him to program in 10 years, and this is an example out of this paper. So Dave is creating a poster. And Dave, can everyone read that, by the way, that programming example? Dave has a file, and he pays for openbox.org to host all his files. He's got 5 terabytes on that OpenBox server, and he pays for that server to be up. And it scales, so if he goes over 5 terabyte, it will just scale up automatically. Dave decides to create a new file called poster at openbox.org. And the only thing he has, the only thing he has to do is do new file event at openbox. And this will trigger, this will be compiled, and in the interpreter, this will trigger to create a new object of the type file on openbox. So Dave now, sitting at home, has created an object on some server somewhere, but he doesn't care where it is. Because we stopped caring about our personal data anyway, so why do we care where the programs run? You know, so he says, okay, openbox, you create this file. And then he says, oh, okay, I need a calendar for this event. So he says, oh, okay, I know this free service called calserver.net. So he creates, and maybe he might register for this, or you don't know, but he creates a new calendar object on calserver.net. But you've got no idea where this is, you've got no idea on the underlying technology, but it's easy. One might be in China, one might be in America. But now you've got 2 objects living on these 2 servers. And now he says, okay, I want to create an event in this calendar and save it to that file. So he does, he calls a function on this object, which lives distributed, and passes in a parameter. And then he adds this line, or this event, to his file object. And for that, he can save the event in the file, and it's all happening in the cloud. So basically, when you do a file.add line and you pass event.value in, what will happen is that the event is actually a pointer to cal, and that's a pointer. So you have pointers into the cloud. So you've got this big cloud where you're not locked in anymore. You're locked into whatever service you choose you want to be locked in. So your OpenBox is your file server. But if, let's say, another company comes along and says, oh, we have the same API as OpenBox, but we're cheaper, it's very easy to change because the only thing you have to change is replacement openbox.org, and all your objects instantly are on that server. So you're not locked in, and it becomes very scalable because you rely on the scalability of the cloud provider that he will scale up. If he has 1 terabyte and he will want 2 terabyte, that's very easily done for the cloud service provider. So it's very easy to swap. And the bottle, yeah, that's in big. I'll go back. So yes, the bottleneck nowadays is the last copper mile, it's called. The servers, when I sync a server that's in America and a server that's in the Netherlands, they sync with 10 megabytes a second. but my download at home is, if I'm lucky, 600 kilobytes. So if those two servers would actually start communicating, they'll be so much faster than my computer, even just because the network is so much faster. So if you do all the processing between different servers in the cloud, you gain speed. The network becomes irrelevant. Everyone says, oh, network speed is a big thing. But the servers are linked up. Google and Amazon, they are going to be so quick to communicate with. If Google and Amazon try to contact each other, that will be so fast that you couldn't even dream of something at home like this. They've got a dark fiber, I assume, to each other or something. So the event.value, what actually goes off to another server, so OpenBox will contact the CAL server. That'll be very quick because they're on the internet backbone. You, the bottleneck, the last copper mile, is not even contacted when this happens. You get the reply, okay, it's happened. And that's just like a flag. But you're not contacted, so even if you have big files like pictures, movies moving around, it becomes very, very quick, like video encryption, for example. Let's imagine you have a video hosted on some cloud server, and someone provides a very good encryption algorithm. Like AMD is now providing a rendering farm for game graphics. And of course, they've got a massive hall. They've got a race floor with thousands of graphic cards in there, something you could never reach at home. At most, I've seen 4, I think, graphic cards. But they have thousands. They've got programmers sitting there optimizing this. So let's say that Amazon decides to provide a video encryption algorithm, or AMD or whatever. Company named, please replace at random. I don't care about companies. So they have programmers sitting there optimizing their video codec encryption library, whatever. And you host your video on some cloud servers. You can transfer that video. If it's 10 megabytes a second, that's then that's not even a minute. And they've got this massive server farm, and they can parallelize it, and they can encrypt it in a few seconds. Something that your home PC will take hours to do. So you gain a whole lot of speed through this process, and you can offload to professionals. So I sat down and started writing a compiler where this would be possible. And I just wanted to see if it worked, because I had a bet with a professor, and he said, oh, it won't work, it's too complex, and SOAP is shit. Rant. And I said, no, I think we can do this. And at the end, I got quite a few beers off him, because it did work. And so I started writing object. And object stands for object in the cloud. And it's a compiler infrastructure and a VM. And my first attempt was actually to have a compiled file, because I thought it would be really nice to have a compiled file with a very, very slim VM. But this is not possible, because it's if the network connections are too complex for a very thin sort of, binary format to achieve. So you have quite a strong VM. So what the design at the end became is that you have your compiler and you have your server infrastructure. And the compiler obviously has a source code, and it creates an abstract syntax tree. It tokenizes, creates an abstract tree, and it creates a bytecode out of that abstract syntax tree. It does some optimization, so basically a for loop becomes a while loop and stuff like that. So some very basic optimization stuff that will never be reached are cut out of the abstract syntax tree. And but the syntax tree is still kept in the bytecode. So in my VM or runtime environment, I can do abstract syntax tree optimization. So if I have a for loop, or a while loop in this case, I can see this branch is a while loop, and I can do special algorithms on that. Some people disagree with that, but I like the research topic of abstract syntax trees, so I read a little bit into that. The core element is this bytecode, and the aim of this bytecode was to be extremely portable. The aim was that I do not care what system interprets it. So if it's a Sun machine, the idea is if you copy this bytecode, it will run on pretty much any machine. And it sort of seems to work. And then you have the other side, you have the server infrastructure. So now let's assume you have objects. And you don't want other people that have objects on that server too to access or to see the data in that object. And so what happens is every time you create an object on a server from the class file, that is described in the bytecode, by the way. It's pretty much like Java. You have your class file, and from that class file you instantiate objects. So the structure of the object is described in the bytecode, and then the VM initializes it and creates an object. And the VM, for every object you create, there's a new VM. And they have an own memory segment, they have an own stack. So it's not possible, well, in theory, of course, if someone becomes root, it's possible, but it's not possible for, if you have one object, that object is doing something, to see data from other objects. And that's, in my opinion, quite important, because I want to rely on, if I have my emails hosted on some service, I have lots of mail objects on that server, I don't want other people to see those mail objects. Of course, the provider can see them, but that's always, if you go into the cloud, that's always the case. So you have the server here, and that forks many VMs that create objects out of the bytecode, or out of the class definition that is described by the bytecode. Does that make sense? Yeah. Yes.
Hi, sorry. I think I'm getting a little lost. Where's the server?
Yeah, okay. So the server is any service provider that wants to publish his object. So Amazon, Google will want to publish mail objects. So you have servers are just cloud providers. So in my example, it was OpenBox and Cal server or something. Those would be servers. And they publicly advertise, you can create objects on my server made from these class files. So, of course, at some stage, I'm hoping that people will say, okay, you can upload your bytecode and we will instantiate this for you. So we will have object servers living. But for now, or the trend, I'm seeing is that people want to provide objects to the outside world. So I talked to people from HP about this, and they said that they want to provide objects to the world. They don't want people to upload their own objects. So servers is whatever who wants to provide this. And then, okay, and then you've got the O-run program. And that's basically, if you know Java, that's a Java program. That will actually start the communication. This will actually kickstart everything. But the important thing here is everything lives on the server. So if you write a program, you will have that program living in a server, maybe locally to you. But it's possible to program everything on some cloud service and then just instantiate it with O-run. And the only thing, O-run, the script, is 5 lines long. It opens a connection to the port, to the host you give it. I'll give you an example. And says start, or calls main. So a lot of people, I think, have already thought about this, that the communication between these servers, you've got a hell lot of communication between all these services now. And so I started reading up what is there around. And SOAP is becoming is the main thing thought for this, or RPCs. And so I read a lot about SOAP, did a lot of research on SOAP, and I hated it. It was so verbose. For something simple like calling a function, the setup you have to do is immense. So I thought, this is bollocks. I can write something better than this. The usual programmer syndrome, I suppose. So I created the object protocol. And it's an extension to HTTP. It's quite simple. You can read it. It just says, call this function. The return value of this was this. It's just an extension to HTTP. Through this, though, we gain HTTPS pretty much right away. So you can encrypt the communication pretty much like that. So I did some tests. I wrote a function call in SOAP, and I actually optimized it quite a lot because I taught myself SOAP while writing this program. And then I just ran one call in object, and you can see the file size of the SOAP is massive compared to the object. The system calls required to parse it, the SOAP, is immense. And if you look at the parse time, you've still got quite a difference. And time is vital, especially if the networking is still the bottleneck. And we're getting into a situation where every phone is so powerful that the communication is a bottleneck. The network is at what you're actually waiting for most of the time. So, yes. So no one can read that. Am I assuming that correctly? So, wait, okay. I'll read it out. So basically, this is an example of the object language. This is, and I want to sort of describe how this will work. So you've got your So basically, this is the merge between C, Python, Java, whatever languages I sort of have to program in. I sort of try to take the best things out of everything. And I tried to make it a little bit Lispy, but that went totally wrong. And so basically, you just say def main, and that says, okay, this is your main function. This is your main entry point for your class. Basically, this is a class file. This will be compiled to the bytecode, and then you can obviously ship this bytecode to any server you want, and it will then be instantiated. So, and then I say, okay, read the args that I pass through the program. I create ints. I create a new return string. So now it would be possible. Let's say I do some complicated stuff on this string, like hashing. Let's say I want to hash this string at some stage. Hashing on my local PC might be quite slow because I've got an iPod. This program might run on your iPod. So hashing would be very, very slow because it's very process intensive. So I just say, okay, this string should be created on stringserver.net that I happen to know has loads of really, really intelligent PhD students sitting there writing the hashing algorithm that will be really, really, really quick and intelligent, I don't know what. Far better than I would ever write. So I just say, a return buffer equals new string at stringserver.net. And stringserver is so nice and gives me the service for free as long as I don't create too many string objects. And so they have this whole render farm and they can hash it so much quicker than I can. But I don't actually care about the value till I actually output it somewhere, I do something about it. So actually I can just say hash it and keep it. And I might come back to this at some stage. And then I have a for loop that calls the multiplier. You see I call me.multiply. Me is this or something, it refers to yourself. And then I pass in the value that goes up there. And actually, you can see no, I don't create something remotely. But it's possible to basically every object you create to have on another server. Is that clear? Is that understood? That's the important thing. And then, so let's say you finished programming this and you ship it somewhere, and then you just call Python. It's all written in Python, pretty much. A few modules I'm sort of starting to streamline in C. The network libraries are going to be written in C and stuff. But for now, everything's on Python. So you just say object, the run file, the compiler, sorry. Object C is the compiler, the CC. The example's multi, and then you can just say orun multi with a parameter 5, and it will type out 0, 1, whatever I do in my loop. And so it would be possible to write orun classserver.net multi 5. And then the class, if I've uploaded the class onto classserver.net, so it'd be possible to do all this on a different host. If I don't pass in the parameter, it will assume localhost. So this is very nice if you're developing a piece of software. You develop it on your local machine, and the only thing you have to do is upload your class files onto a server, and instantly they're available for the world. Or let's say you develop locally on your laptop, you have all the objects locally created on your laptop, but then you want to say, okay, I want to distribute this, and you just say all int objects are going to be on that server, all string objects are going to be on that server, and you can buy specialized hardware for your ints. And then you're noticing, oh my god, okay, this program is going to be really popular. This is not working out. My servers are sort of getting full. You just say, okay, all in, and then you can call Amazon and say, okay, I need 200 machines. Half a minute later, you have 200 machines. The only thing you say is now all the int objects are on the Amazon server. And then, so you gain scalability in a way that you can write an application, and if it really kicks off, like hack tags, what I showed at the beginning was a program. As I released it, the first thing that the server did was put its ears up and said, too many requests. Because obviously I sent it to my friends sent it to their friends, and in half an hour, I had a few thousand requests a second, and the server just said, that's it. If I would have written hack tags in Object, I could have noticed this and said, okay, buy 10 more machines and start putting the objects somewhere. And I might have to pay for it, but I wouldn't lose the service. Yes. So features of Object. It's distributed object instantiation, what I've been talking about all the time now. It's got base objects, user classes, stacks, conditionals. It's memory management. Memory management is very hard, distributed. pretty much impossible in my eyes. I've read a lot but getting circular dependencies on different servers is near to impossible. I mean, even with 3 servers, figuring out if that object points to that object points to that object, and that points to that one back, figuring out that there's no user in that loop is very, very hard. I don't know, hopefully I can do a PhD on this. While breaks, for, you can have user function, it has returns. Everything's running in an object server. What I was talking about, that's really important. You can have everything in an object server, and because everything's running in an object server, everyone who implements this server can run your program if he chooses to do so. And user classes, again, because I was so proud that worked. Problems. Object versioning problem. Let's say you use int objects on intserver.net. Now they find an error in their, add function. If you pass in a too big number, you add it with another too big number, it returns something wrong. They fix this on their server because they think, oh, this is an error, we'll fix it. You've written your program and you've known about this error, so you've written this massive conditional, if I add these 2 numbers, split them up, and you've written all this extra code. But now actually it's wrong because the add is correct. So there was a thing in Java where the sort was wrong. And if there were more than 10,000 entries, the sort would sort incorrectly. They actually had to leave the error in because so many programmers knew about this that they accounted for it being incorrect. And if they would have fixed it, they would have broken thousands of programs. So they had to leave a wrong sort program in, and now it shouts at you and says, don't use this, this is broken, use the more improved quick sort, I don't know what they call it then. And, but they still have this .sort function in there, and it's broken. So you don't want it to happen that the server provider notices an error, fixes it, and your program will return wrong because you will not notice that happening. So every object needs a version number, and needs a version number if it's backwards compatible, and if the API stays the same, and. Sorry. Inheritance is quite difficult because you want to inherit for different objects. You want to inherit, let's say you inherit a mail object from Google and you inherit it somewhere else. You may want to extend something, but you still want to be able to talk to your base object. Now that turns out to be quite difficult because what happens if that base object dies? What happens if the network connection fails? And. Public-private is basically a big problem because once you've got everything on the internet, you want to be very careful about who can call this function. If you publicly advertise a remove function for files, someone will find this, and someone will remove files on your server. So it's not enough to have just public or private in the sense of the VM. You have to see public, private, and global for the whole world, and public, private for the VM, and then maybe for the subnet, and. So you need a very fine defined access model, which requires a lot of work to actually understand this whole thing. Security is a big issue because even if people don't care now where their mail is, they might care where their bank data is. I don't care. And Google has this medical thing, so Google knows everything about your medicine history in America. And people use it and don't care about it, so I think that's quite worrying. But I think security is very important. But in a way, you gain security through distribution. It's not really security, but if you have one file on that server, one file on that server, and the processing on that server, they'd have to hack all 3 servers to understand it. Now, if you only use Amazon, they have to hack that one VM you're using, and they have all your files. Now, in Object, they'd have to hack the whole infrastructure. And it's actually possible to encrypt, let's say you have a string, you encrypt it on your local machine, and you only have the storage on the remote machines. And then when you get it back, you decrypt it again. There are features like this. And of course, there are certificates, so if the servers have to talk to each other, they can get certificates and stuff like that. As I mentioned, garbage collection is very hard. Now I do it with reference counting, but that's quite inefficient. And if a program crashes, I still keep the reference. So there's an old pool. What's possible that the server, as soon as an object is in the old pool, it will be copied to swap, and then there's an option, if it's been in the swap space for longer than a week, it will get deleted because you can't assume that will be. But it's very hard to see if a program crashes or something, what should happen was the remaining objects. And there are hundreds of problems more. I mean, I could go on forever about the problems. The future of the cloud. I think it's not possible that the cloud stays in lots of separate subclouds. It will have to change, and there are initiatives of actually changing this already. And so I think the cloud providers will have to start talking to each other. And the big ones will define some sort of standard, and then all the little ones will follow. But there will have to be some sort of standard how you can actually access your data in a defined way, and how you can process your data in a defined way in the cloud. More data will go to the cloud. Rely on it. I mean, I'm just waiting for the police services to move all their data into the cloud or something because it's cheaper. Companies are mad for it. I don't know why, but as soon as you say cloud, they start chucking money at you. It's quite weird. And I think the time where people have massive PCs under their desks is dead. For us developers, maybe. We will need some development machine. But I'm seeing a trend for people to have an EPC maybe, and the EPC was like the first step in this, that you have everything on Google Mail, Hotmail. You have your docs in Google Docs. I mean, Google, the Chrome OS is like the next step into this area. People are now replacing their desktop machines with iPhones. So I've met a guy, and he says he only has an iPhone. He does everything on an iPhone, his email, his doc processing, everything. He has a keyboard he can somehow connect to it, and then he does everything on an iPhone. So I think the times where you have these big machines under your desk are over. For the normal user, I mean, in all respect, I think I'll never give up my servers at home. So for Object, the future holds a lot. I want to have more failover structure. I want to have caching, more caching than it does now. I want a modeling notation. I'm actually, if someone's interested, I'm writing a paper about this right now, about how you can model all this, because there's no cloud modeling language. We have UML, and then it stops. So I've actually started thinking about how can we model clouds, how can we model that we've got data in the cloud. There's no modeling for this. So I've started creating a modeling notation that sort of extends UML to describe this. Payment would be really cool. Just imagine you could, for every video encryption, you pay 0.01 cent, and you can encrypt your video, and it's in a second or something, half a second. Authentication. There is a basic authentication module now, but I want a proper OpenID sort of authentication, that if you hold this authentication object, you can authenticate to many services. Different output filters, and more encryption. I need your help. It's me doing it. So if someone's interested in contributing or helping, please. I've had a little bit of contribution after talking about this, and people have started helping. But if you're interested in this, talk to me, and I'm sure I can give you some work. It's interesting. Now the fun part. Now you can quiz me. I'll run around.
I have a couple questions. So I think I'll start with the easy one, which is, do you have something like remote pointers or handles so that you can pass a reference to an object around? Okay, that does exist.
It's host name. It's a pointer object now. It's host name and a hash. But you can attach to this. You can attach authentication details, so certificates or encryption, or you can add notes to it in a way. But in theory, it's enough to have the name, the host name, and the hash, and you can have access to this object. Yes. If you define it as such, you can. Of course, if you add a certificate to it, it becomes it becomes private, because only who holds a certificate can access this object. The first thing when you access this object will be certificate, please.
Right.
Yes.
Okay. And so the next question maybe is, it seems like there's a bit of wheel reinventing here. Like you created a proprietary, well, you created your own protocol for doing function calls, and there's XML RPC, there's JSON stuff, there's Google's doing their own binary stuff to replace XML and things like that.
The problem is that none of those really include memory management, and all of them are RPC. And RPC is thought by big corporate companies. Oh yes, we have to call a function on that server. And there is no authentication. I mean, Corba goes in that direction. Corba is very much in that direction.
Right.
But who has actually programmed Corba?
It's the devil's tool.
Exactly. I mean, in my opinion, it's too big. XML, it's just too slow. parsing
It's like X500. It was designed by engineers in a vacuum.
Exactly, and everyone uses LDAP. I mean,
Exactly.
So I think it's just overblown. I think I like small sizes protocols and quick and speed and.
Okay.
Yeah.
Well, I mean, to be honest, I think the main wheel of reinvention that worries me is you write your own VM and your own language.
I mean, you can write the whole thing in Haskell, apparently. Some guy told me, oh, yes, that's very simple in Haskell. And I said, okay, if you write this in Haskell, I'll buy you a dinner. And he said, actually, it was at Frostcon in Germany. And he said, oh, yes, I can do this in a few hours. I said, oh, okay. I'll invite you for a really nice dinner, 3-course dinner. And please, show me something. And I gave him all my code and everything. I said, please, and I'll help you. If you have any questions, please. And so he stormed out and started hacking. And half an hour later, he said, yes, I'll email you. I haven't heard of him since.
Well, I guess I'm thinking of, because there are a number of virtual machines, and maybe, I guess, I'm not sure what the motivation was to not extend one of those.
I wanted to write a VM.
Okay. Okay.
Basically, this project too, it was my bachelor's project at university.
Right.
I wanted to write the whole compiler stack myself.
Right.
I was looking at the Python VM and stuff like that. And I've worked on the Java VM and stuff. And I thought maybe I knew how to extend the Java VM to do this. And it's possible. I suppose I could do it in 2-3 months. I could get the Java VM with a lot of tricks to do this. But I wrote this in 2 weeks or something, the VM. So it was quicker, it was easier for the project to do it like this. Obviously, if I would do this, if I would have enough time, I was thinking of using the Python VM and actually extending this to create a Python syntax that's very similar to Python, because I think that would be quite nice.
That would be sexy.
Yeah, exactly.
You get much easier if you have a lower learning curve for users.
Exactly,
Yeah.
and of course, like especially in the Java VM, you have 30 people that are far more intelligent than I think all of us in this room, that have optimized all these funky and JIT, and I don't know what they do. And it's amazing what the Java VM, I could talk about this another hour, how amazing stuff in there is. And if you would extend that, I mean, it would become amazing, but I don't have the time to do that.
Okay.
So, someone else? Please? No? Okay. Thank you very much for listening.